to the CMG Tech Bytes videos. My name is Diana Mercado and I will be showing in this video how to do the well definition using grid independent well option. After CMG 2021 version, we have two options to define well locations and flow connections in the simulation grid. The first one is the UVA-based location. In this case, each well perforation is associated to a grid block in the simulation model using the user block address or UVA. The UVA is a natural extension of the familiar IJK notation for addressing blocks, but allows the user to refer to any block in the grids available in CMG simulators. The UVA starts by giving the fundamental grid block in IJK notation. For example, in this case, we have a producer well perforated in the grid block 16 in I direction, 28 in J direction, and 1 in K direction. Now, we provide to the user an additional option that allows to define well perforation and associated index parameters in terms of measured depth. This is the grid independent well option. Now, we will show you through an example how to define a well using the grid independent option. In this case, we have an injector well with two sections, the first WB1 and the second WB2 attached to the WB1. To define the well shifting, we use the instruction WB shift. To define the well trajectory, we use WBranch. And finally, to define the well perforations, we use perf_nd. Let's explain more in detail each of these instructions. To shift the well branch location, we will use WB_shift instruction. This optional keyword allows to the user to reallocate the well branch without altering the original input coordinates of the well trajectory segment. In this case, we define the well or wells that we want to define the location shifting. After that, we define the increments of the coordinates in X, Y, and Z directions. The default values for these increments are 0. In the figure, we can see two wells, well 1 and well 1B. The only difference between them is the values used in the X, Y, and Z coordinate increments. For example, in this case, for the well 1, we have 1, 1, and 2, and for the well 1B, we have 100, 120. With this, we can see how too easy it is to change the well location in the model. Now, we need to define the well branch trajectory. For this, we use the WBranch instruction. In this case, we define the branch name with the must be unique in the dataset. After that, we input the name of the branch parent, or for a main wellbore, the well name. In the following columns, we define the coordinates in X, Y, and Z to define the spatial location of a point in the branch, and finally, the measured depth of the point in the branch. In this example, we define the trajectory for a parent well and the trajectory for a branch well. The main well branch is the only well branch connected to the surface. Now, it's time to specify the location of the well completion intervals in terms of measured depth using perf_nd. For each branch, we specify the measured depth for the start and end of the well completion intervals, as well as status in terms of it is open or closed. Some of the advantages that can be appointed for grid-independent well option are that it's more easy to reallocate multilateral wells, It's not necessary to redefine perforations in the case of recurrent grid changes or infill well location optimization. And this new option is especially helpful in CMOS studies where well location is set as a parameter in optimization or uncertainty study.
Converting grid-based wells in existing models to grid-independent wells can easily be done using Builder 2022. Let's show you a demo about how to create grid-independent wells. To create grid-independent wells in a model, it's necessary to have the well trajectory. So, if the model doesn't contain trajectories, we can import the trajectory from an existing trajectory file using the Create Import Well from Trajectory Data option. For this, we can go to Well menu and select Create Import Well from Trajectory Data. Another option is to create the trajectories from completion, selecting well trajectory and create trajectories from completions. In this case, we will create the trajectories for all wells. Click on OK. Once trajectories for the well have been created, we can observe that the well is still represented as a grid-based well, opening the perforation dialog. In this case, we select the Perforations tab, and we can see that the well is still as a grid-based well because the user block address and connect to information is defined for the completions. Click on OK. The next step requires convert to grid-independent wells. This option is available in the Trajectory Perforation Interval option. For this, we can go to the Well menu and select Well Trajectory and Trajectory Perforation Intervals. In this window, we can see the grid-independent column that will contain one checkbox for each well that has a defined trajectory. If the checkbox is selected and the changes applied, then the well will be converted to a grid-independent well. If the checkbox is unchecked and the changes applied, the well remains as a grid-based well. In this case, we will select all the wells with trajectories, clicking on the button, select all in the grid independent option. The grid independent options provide simplified selection options for dealing with many wells in the model. Click on Apply, and this message indicates that the existing completion information has been updated to match the requirements for a grid-independent well. Click on OK. And it's also important to note that all options in the Trajectory Perforation Intervals window are available for grid-based and grid-independent wells. Click on Apply and OK. Let's come back to the completion definition and let's to the perforation tabs, and in this case we can see that the well is now identified with a branch name and a perforation interval with a measured deep range to the start and end of the interval perforated for this well. Click on OK. The grid-independent wells can be rotated and shifted, which can make parameterization through CMOS possible without requiring running Builder silently. So a well that is independent of a grid simplifying the CMOS studies where rotating and shifting the wells is important in the study. This option is available for a grid-independent wells that will allow to reallocate the well without modifying the original trajectory, and perforation measure deep intervals. This option is available selecting the menu wells, well trajectory, and trajectory properties. In this area, in this window, you can select the tab nodes, and in this area you can see the option rotate and shift that you can introduce or input values in order to rotate and shift the well. All of these parameters you can to parameterize in CMOS in order to reallocate the well position in the study. Click on OK and let's save the file. If you open the dataset in CEdit and go to the well definition, you can see the wells defined as a grid-independent well format using W-branch keyword and the perf ND for the interval perforated for this well.
Thank you very much for watching this video, and remember to click like if you consider it, and subscribe to our channel and turn on your notification so you are informed about our future technical bites and publications.